Hello everyone, welcome to chapter 10 of the Java tutorial, which is about operators. In fact, we have used operators before, for example, the plus operator or the assignment operator. However, today I'm giving a more comprehensive overview about the different operators that exist in the Java language. Okay, so what can we do in general with operators? Basically, we can manipulate variables or combine multiple variables to more complex expressions. And in particular, if you consider the previous chapters, there we have used already logical expressions, for example in the if statement. So the if statement allows us to branch into different parts of our program. If a certain condition holds true, execute this part of the program, else execute this part. And for that we need logical expressions, and for that we need logical operators. For example, we may have two Boolean variables, a and b, and now we can combine these two Boolean variables using the logical AND. So a and b, both of them could hold true or false, and depending on these values, well, of course, we get different results from this logical AND operation. Only if both a and b are true, then this combination with the logical AND operator is true as well. We also have the logical OR. Here, if either a or b is true, or both, then the whole expression evaluates to true. And finally, the negation, that is of course turning true into false and false into true. So if we have the current value in a equal to true, then not a will be false. Here a short example. So that's one class with a single method, namely our public static void main method, and I'm first of all introducing two variables of type Boolean, namely it rains. Here we say, yeah, today it's raining, so that's true. Then Boolean, I have an umbrella, that's false. Maybe I forgot my umbrella at home, and therefore this variable is false. And now I'm computing from these variables, I'm computing whether or not I get wet. And the result is again either true or false. Okay, how can I compute whether or not I get wet? If it rains and I have no umbrella, then I get wet. And in all other cases, I'll get dry. I stay dry. So that means now I can output my current state as follows. If I get wet, so only if the current value in this variable I get wet is true, then this branch of my program is executed. Namely, we are printing now system out.println. I'll get wet to the console. And else, if I don't get wet, then I print I'll stay dry. Okay, so that's the main idea. Here we use logical AND the negation to combine two Boolean variables, and the output is then, or the outcome is then another Boolean variable. Well, that's how to work with Boolean variables. Of course, it's maybe more common to work with double or integer variables, and these there it's very common to combine them using these arithmetic operators, plus operator, minus, the multiplication with this asterisk symbol, the division with this slash symbol, and this is maybe not so common, the modulo operator, which is displayed here with this percentage symbol. And what is the modulo operator? Actually, it computes the integer remainder of a division. So if you try to divide 11 cakes over 3 people, every single person will get 3 cakes, and then you are left with 2 cakes, which you can either break into pieces or keep as a remainder of the division. And here 11 modulo 3 is just 2. Well, then we have arithmetic operators used to increment or decrement the values within a variable. So for example, we have the increment operator plus plus, which is then, for example, written like this, a plus plus. It means take the current value within variable a and increment this by 1, and that will be the new value within this variable a. So accordingly, we have now the same meaning as with this expression. So a plus plus just means a is equal to a plus 1. A plus 1 is the increment of a, and that is then assigned into the variable a. So that will be the new value in that variable. Well, this comes in two different forms. Either we have a plus plus or plus plus a, and I will explain in a minute what the difference between these two forms is. But before I come to that, let's talk about the decrement operator. Of course, that is straightforward now. If we have a minus minus or minus minus a, well, that has the same meaning as a is equal to a minus 1. So the current value in a is evaluated, then 1 is subtracted from that, and the output is then assigned to variable a. So then we have decremented a by 1 value with this expression, a minus minus. It's kind of a shorthand for this expression. Let's get now to the difference between a plus plus and plus plus a. So the difference here is that, of course, such expressions like a plus plus often occur within larger expressions. So here, for example, we take variable a, current value is 2, and then what we do is basically, first of all, we print the current value in a to the system output. And only after that, so after this whole expression here is evaluated, only afterwards this incrementation is performed. And only then we continue with the next line of code. So this, if this a plus plus occurs like this, that means this increment is always performed in the very last step of this whole expression. On the other hand, we may have plus plus a. Well, the example is still almost the same, except that I changed a plus plus to plus plus a. And now what is done here is that first this increment is performed. So what was before 2 is now 3. And afterwards, the result is then printed to the system output. Accordingly, we will see output 3 in this example. Whereas here we will see output 2. That will be the current value in a, and only after this output a will be incremented. Well, then we have what is called assignment operators. You know this assignment operator already. That is just the common assignment where you have a right-hand side, and this right-hand side is then assigned to some variable which is to the left of this operator. Well, however, there are also other assignment operators. For example, you will see this quite often in the code, maybe a plus equal b. And I should point out again, well, that's kind of similar here as with the a plus plus. So this is just shorthand for some other command. Basically, this a plus equal b is shorthand for a is equal to a plus b. Yes, so the current value in a is evaluated, the value in b is added to that, and the outcome of this sum is then assigned to a, becoming the new value of variable a. And this plus equal, that, well, in a very similar fashion, you can also apply to minus and multiplication, division, and modulo. So for example, a slash equal b has the same meaning as a is equal to a divided by b. Division is evaluated first, and then the outcome of this division is assigned here into variable a. If you write it like this, it has the same result and the same effect. Just as an example, this we had before. We had a class point with attributes x and y. I'm not showing the attributes here, also I'm not showing the constructor, but then we may have a method void translate. So that's an instance method within this class point. With this I can take some point p, for example, and translate it by some amount in the x direction and some amount in the y direction. And what we do then is just that we read the current value in this variable x and we add this dx to it to move our point, and the output of this sum, or the result of this sum, is then assigned to this variable x, becoming the new x coordinate of the point. And the same I'm doing here with the y coordinate. So that is how to translate a point using an instance method. And of course here, what you see here, this y is equal to y plus dy, it has exactly this form, a is equal to a plus b. So what we can write instead, therefore, is just x plus equal dx, y plus equal dy. This is shorter, easier to read, less effort for programming, and therefore this form is usually favored. Well, then there are operators for comparisons. For example, if we have two variables, maybe they are of type double or of type int or something, I can test whether the values within these variables are equal. So that's the test for equality. That I do with this double equation symbol, or double equal symbol, I should say. Yeah, just that you should really distinguish. There is this single equal symbol, which is an assignment. And then we have this double equal symbol, which is a test for equality. So this whole expression here, this a equal b, that will be evaluated to true or false, depending on the values within these variables a and b. Whereas a with a single equal symbol, b, would be just an assignment. So the value of b would be assigned into variable a. Okay, then we have also the test for inequality, the test for greater than or equal to, the test for less than or equal to, the test for strictly greater than, or the test for strictly less than. And of course, especially these comparison operators, they are particularly often used in if statements. Yeah? So if a double equal b, then do something. Yeah? So that is basically where these comparison operators are often applied. Well, to give you also an overview of these different operators, I have here this table. And well, if you have more complex expressions with multiple of these operators combined, then it's always not so easily understandable what is actually happening when this large complex expression is evaluated. And there it's important to know that this evaluation of the expression that follows a certain rule with respect to the order of how these operators are applied. First of all, first are applied these unary operators, meaning operators that are applied to just a single variable, like a++ or b-, or -c or +c. Well, this is actually quite uncommon to have just this plus as a unary operator, because the +c just keeps the sign of c. It doesn't do anything. So this is maybe used to highlight that we keep the sign of some variable. So it's maybe used as well, a way to improve the readability of the code, but it is actually not doing something. Or the negation symbol here, yeah? So that is also a unary operator because it is applied only to one logical variable, not a, something like that. Also, then we have these casting operators, yeah, which we used to convert, for example, from double to int. There we needed this explicit type conversion, casting, and that is what we have here. Well, then we have already here, that's actually also a binary operator, the multiplication, division and modulo, because it combines two variables, yeah, a times b. But here, this is actually now the arithmetic plus and arithmetic minus, so that's a binary operator, a plus b. So this unary and binary here on my slide is to distinguish this plus and this plus, or this minus and this minus. This unary minus here is always just changing the sign of some variable, and this binary minus here, it's computing the difference between two variables, a minus b. That's where you need to be careful about the evaluation order. Yeah? So this minus is actually evaluated with a high priority, versus this binary minus here that comes rather late in this evaluation order. Then we have the comparison operators, less, greater, less equal, greater equal. Then we have the comparisons checking for equality and inequality, not equal. Then we have the logical and, the logical or, and finally we have these assignments. So the assignments are evaluated last. That's the evaluation order. Well, so in general, this follows the rule, multiplication and division first, then addition and subtraction. Well, if there is any ambiguity left, maybe you have, for example, a times b times c times d or something like that, then the evaluation is from left to right. There's one exception, of course, when having an assignment. For example, like this, y is equal to x is equal to x plus 2, then you need to read this from right to left. So for assignments, the evaluation order is from right to left. So this is evaluated first, x plus 2. The result is maybe 7. This result is then assigned here into this variable x. So before x was 5, but now x is 7. And now this result is assigned into this variable y. So y is now also 7. Assignments are read from right to left. What I would also like to point out is, of course, you can use round brackets to enforce a certain evaluation order. Yeah, so you would like to write something like round bracket a plus b, then the closing round bracket times 3. And of course then this plus is evaluated first because you have wrapped this term in round brackets. It's the same as you are also using in math, of course. If you use round brackets, that defines also the evaluation order. And I would suggest that even if these round brackets are not required, please use them to make the expression more readable. Because maybe, of course, not everyone knows about these rules. Yeah? So it's actually quite hard to remember all these rules. So therefore, it's always a good idea to include these round brackets, showing the evaluation order that is applied, making it much easier then for others to read and understand your code. Let's look at one example. This is class myCalculation. It has just a single method, public static void main. There we have one expression like this. It's 1 plus 3 modulo 2 plus 1. And of course, modulo is evaluated with a high priority. So what is 3 modulo 2? Modulo 2, it's 1. So the integer remainder of this division is 1. And therefore, now afterwards we evaluate this plus. So 1 plus 1 plus 1 is 3. So the result would be a is equal to 3. However, here I have introduced these round brackets to kind of increase the priority of these operations, the plus operations. Yeah, so now we have 4 modulo 3. And now what will be the outcome then? 4 modulo 3, the integer remainder of 4 divided by 3 is 1. And now, of course, if we run this program, we also see a is equal to 3, b is equal to 1, as expected. And that is, of course, how to apply these concepts. As I said, it will improve the readability of your code or if you place here these round brackets, even if they are not necessary. Yeah, so this does not change anything, but it makes your code easier to understand, because even programmers who are not familiar with these rules of priority, they can now understand your code. That's it for this session, and in the next chapter we are dealing with visibilities. See you then, and bye-bye.